One of the fundamental principles of computer science that I believe anyone needs to have at least a basic understanding of before they dive into coding, learning how to program, is learning how to convert numbers into binary. And also just kind of understanding what binary is. So I have an example here on the screen on how to relate binary and how it represents numbers in relation to what most people are more familiar with, which is base 10 numbers. So when we have our base 10 numbers, we can think that the positions of our numbers have a value associated with them in multiples of 10. So if we have a single number, the number 1, then it's simply equal to 1 because it's in the ones place, which has a value of 10 to the 0. However, if we had another number there, the first number would be in our ones place, so still equal to 1, but then the second number would be in the tens place. And of course, has a value of 10 to the 1, and we have 110 here. So 110 plus 1, 1, and we have 11. So this is what most of us grow up learning in school. That's why it's easy for us to wrap our heads around having a base 10 numbering system. Computers, on the other hand, typically, most systems communicate in binary, which means they only have two numbers, either a 1 or a 0, to represent data. So all this means is we're going from a base 10 to a base 2. And as far as what that means, well, I have it backwards from the tens place here, but still we can understand that if we have a single number, either a 1 or a 0, let's just say that it's going to be a 1, that would be in the 2 to the 0's place, and that just equals 1. But what if we had a second number? Let's say we have a 0 and a 1. So the 0 is in the first place, but it's a 0, so it's equal to nothing. But then the next 1 is in our second digit, which is worth 2 to the 1 power. So in this case, we have a value of 2. So looking at a 4-digit binary number, 1001, we can look at the places here and we can do some basic addition to convert this number to its base 10 represented number. So we have a 1 in the first place here, so that's equal to 1. The next two zeros are zeros, so nothing here and nothing here. And then the fourth digit we have, which is 2 to the 3 power, which is equal to 8. So in this case, we'd have 8 plus 1, which would give us 9. And just to confirm that, we can use very simple command in Python, which is an awesome language we'll cover in a later video. A great language to start learning coding if that's something that you want to do. We can use, two different things we can use. We can use the bin command, which will take a base 10 number and convert it into binary. Or we can use 0b in front of a binary number. And it will give us the base 10 of whatever this number might be. So in our case, we have 9 here and 1001 here from our previous example. So if we run this, we can see in the screen below that 9 is represented as 1001 and confirmed on the second line. It converted, I had a typo there. That's not right. It converted 1001 to 9. And there you go.